Reducing radicals. So this topic is whenever you need to simplify something that's a square root, or this method would also apply to things that are other types of radicals such as cube roots and that sort of thing. But you'll notice that the problems that we're going to work and simplify aren't perfect square roots, but they can be simplified. So the first thing to remember is, what do you mean by perfect square root? So those are these square roots that you can simplify them and the answer is just a whole number and there's no more radical. So the square root of 4 is 2 and the square root of 9 is 3 and so on. Before we jump into the problems that we're going to work in simplifying, there's one property that you need to remember or to learn, and it's if you have a square root and you have any number of items being multiplied under the square root, you can kind of pull apart those square roots, meaning the square root of a times b is the same thing as the square root of a times, separately, the square root of b. So for example, you can use this property to pull things apart, such as if you have the square root of 20, notice that we'll have some motivation to do this in a minute. We might need to factor 20 for something we're going to do. So let's just say the factors we need to use are 4 and 5. So 20 is 4 times 5, so I can surely write it like that. And this property says, hey, if you need to, you can pull apart the square root since you have multiplication of two numbers underneath. This is equal to just multiplying those square roots individually. We'll do something with that in a minute. This property is also really useful to go backwards as well. So if you ever were kind of trying to wrap up a problem and you've got like the square root of 3 and it's being multiplied by the square root of 2, that is equal to the square root, since it's the same radical, of 3 times 2, or the square root of 6. So depending on what math course you're in and what you're doing, you might need to use this property forwards or backwards. I can think of my second example in pink as something that we use in pre-calculus and some kind of problems that we do. Okay, so jumping into the type of problems that we're going to do in this section, we have to keep in mind a radical expression is in simplest form when the radicand, the radical, contains no factor greater than one that's a perfect square. Again, perfect squares are the things that we looked at the beginning. So when I look at the square root of 20, I know it's not a perfect square or a perfect square root. But if there's any factor of 20 that's one of those perfect square roots, it can be simplified. So I won't keep switching back and forth, but just really fast. So that means if 20 has any factors such as 4 or 9 or 16 or 25, 36, 49, and so on, any of these perfect square roots, you want to use those to help you simplify. 20 does have a factor that's a perfect square root 4. Now if it had any more factors that are perfect square roots, we really want to use the biggest factor out of all of our choices, and we'll talk about that in particular in example part E. Because 20 is 4 times 5, and I'm choosing two factors where one of them is a perfect square root, I wouldn't want to use 2 times 10. 2 and 10, neither one of them are perfect square roots, so they don't help me here. So I specifically chose the factors 4 times 5 because they multiply by 20, and one of them is a perfect square root. That property tells me that I can pull apart these square roots and multiply them. And then notice something can be simplified here. The square root of 4 is 2. So I can replace the square root of 4 with the number 2, and then I'm just kind of stuck with the square root of 5 because that does not simplify and it's not a perfect square root. So the simplified version of square root of 20 is 2 root 5. Again, a couple key takeaways. Notice that the number out front came from a perfect square root, and the number that's stuck under the radical is the one that didn't simplify. So taking that same approach with square root of 100, not a perfect square root, or wait, sorry, it is a perfect square root. I forgot, I snuck this in here. To know if it's a perfect square root, is there a number that you can multiply by itself that gives you 100? Yes. And since the answer is yes, then it's a perfect square root, sorry, and the answer is 10. So there's no radical in there because that's a perfect square root. Moving on to square root of 50, it's not perfect, but it does have a factor that's a perfect square root. So you're just kind of running through the list. Is 4 a factor? Is 9 a factor? 16, 25, 36, 49, and so on. And 25 is a factor of 50, so that would be a great factor to use. So this is 25 times 2, and that pulls apart square root of 25 times square root of 2. Simplify any of these radicals that simplify. Square root of 25 is 5. No radical, right, because it's a perfect square. So that becomes a 5, and then we're just kind of stuck with the square root of 2. So the answer is 5 times the square root of 2. Always double check, because if you didn't take out the biggest factor, that's a perfect square root, you would be left with something under the radical that still can be simplified, and you would need to keep going. I will show you that in part E. 18, we've got a factor of 9. That's a perfect square root. Notice I'm not thinking about 6 and 3. They multiply by 18, but neither is a perfect square root, so it's not useful to help me to simplify. But 9 is a factor, and that helps me because square root of 9 is a perfect square root. That is 3. So that's 3, and I'm just stuck with the square root of 2. So the simplified answer for square root of 18 is 3 times square root of 2. It is true, just for making a note's sake, that's the same thing as square root of 2 times 3, but you'll never really see a back of a book write it in the way. It's just more commonplace to write the number and the radical second, like the number first. Another reason why you don't prefer to write it this way is if you were typing that into an online homework system, sometimes after you type the square root, it's hard to get out of it to write times 3. Like it'll accidentally, sometimes people put the 3 under the radical. That's obviously not the same thing. So there's a lot of motivation for writing the radical last, but it doesn't really matter. Okay, moving on to maybe the best example. 48, it has a factor of 4, but notice if you keep searching through the factors of 48, it has a factor of 16. You always want to choose the biggest factor. That's a perfect square root if there's more than one. And we'll talk about, well, what if you hadn't thought of 16 and you just went with the 4? I'll show you that. But if you notice the 16, you're in luck because it's the shortest route to the final answer. Square root of 16 is 4, and I'm stuck with square root of 3 because it does not simplify. So the reduced form of root 48 is 4 root 3. What if you hadn't noticed that 16 was a factor and you went with 4? Of course, 4 times 12 is 48, and 4 is a perfect square root, so you can go this route. It's just going to be longer. Square root of 4 is perfect. It's 2. So I get 2 root 12. Not the same answer, right? What you'll notice is this isn't finished. 12 has a factor that's a perfect square root, so you've got to go all the way until it's completely simplified under the radical. So just keep going, just don't lose the 2 that's out front. 12 is 4 times 3. Again, pull that radical apart, square root of 4 times square root of 3. Again, don't lose the 2 out front. The square root of 4 in the middle, that gives you a 2. There's a 2 out front that was already there. Now there's a 2 replacing the square root of 4, and there's a square root of 3 we're stuck with at the end. And then just simplify, 2 times 2 is 4, so you get 4 root 3, and of course we get the same answer.